Trigonometric equations. We want to solve 3 sine x minus 1 equals 0. So the first thing that we have to do is to simplify the trigonometric equation. We want it to be in a certain form. Add 1 to both sides, divide by 3, and finally I have the trig function on its own. Now immediately at this point I should draw a cast diagram. Very simple cast diagram. This is a sine function and it's positive. Now how do we know it's positive? Because there is no negative on the right hand side of the equation. So where is sine positive? All 3 trig functions are positive in the first quadrant, and sine, as indicated by the letter S, is positive in the first quadrant. What we need to do now is to use our calculators. So x equals sine to the minus 1 of 1 divided by 3. That gives us the answer 19.5 degrees. That's the first answer, the answer that lies in the first quadrant. The second answer, 180 degrees minus 19.5 degrees, which gives us 160.5 degrees. There are 2 answers. In our second example, we've got to solve the equation 4 tan x plus 2 equals 2 tan x. That's quite tricky. So 4 tan x what I want to do is to gather together the trig functions. So I'm going to subtract 2 tan x from both sides. 4 take away 2 is 2. The next thing I'm going to do is to try and get the trig function on its own. Subtract 2 from both sides. Last step, I'm going to divide by 2 to get tan x equals negative 1. Now at this stage we should immediately draw a cast diagram. So the question is, we have a tan function here, but the tan function is negative. Now we know that tan is positive in A and T, which means that it must be negative in S and C. Calculators. X equals tan to the minus 1 of 1. Now you'll notice that the negative sign does not go into the calculator. The negative sign we take into account when we tick the relevant quadrants, but we don't put the negative sign into the calculator. And that gives me, so tan to the minus 1 of 1 is 45 degrees. I'm going to put that working in a bracket. I don't want it to get confused with the main part of the working. And then what we're going to do is we're going to use this 45 degrees. We're going to subtract from 180. And we're going to subtract also from 360 degrees. And that gives me 315 degrees. My 2 solutions. In this third example, we want to solve the equation cos squared x equals 1/4. Now, the problem is, of course, that we have a square here. And the only thing that we can do to get rid of a square is to take the square root of both sides. Now, if I take the square root of cos squared x, which is to say the left hand side, I get cos x. If I take the square root of the right hand side, I get positive and negative the square root of 1/4. Now that positive and negative is very important. Note well. Right, calculators. The square root of 1/4 is 1/2. Now what I'm going to do is to split this equation up to give me cos x equals 1/2, the positive 1/2, and cos of x equals negative 1/2. Use a cast diagram here. The cosine function is positive in A and C. So we can go straight to our calculator. X equals cos to the minus 1 of 1/2, and that will give me 60 degrees, which is the answer that lies in the first quadrant. The second answer is found by subtracting 360 degrees from 360 degrees, and that gives me 300 degrees. Now, for the negative equation, I'm going to draw a cast diagram as well. If cos was positive, as we saw with the first equation, we would be working in the first and the fourth quadrant. But cos here is negative, as indicated by the sign, so we'll be working in the second and the third quadrant. Now, at this stage, I would put into my calculator x equals cos to the minus 1 of 1/2, but I've already done that over here. So what I'm going to do is to make use of this answer. So x then equals 180 minus 60 degrees, which is 120 degrees. And the answer in the third quadrant is found by adding 60 degrees on to 180 degrees. It gives us 240 degrees.